So far we know a straight line has the following equation. A straight line or a linear equation is described by y equals mx plus b. And the solution of the linear equation is every point that satisfies this equation and falls on the line. Now a linear inequality in two variables has the following form. Or excuse me, one of the following forms. We have y is greater than mx plus b, or y is less than mx plus b. And the solution of the linear inequality is every point in one of the plane halves made by the straight line. So we know each half of the plane is the solution by looking at the inequality sign. So let's start by graphing a few linear inequalities in one variable. Let's just keep it simple. So let's look at the first one. We have x is greater than 5. All right, now recall that every line in the form x equals a will give us a vertical line crossing the x-axis. So let's quickly sketch this. It doesn't have to be pretty. So we know that if this was an x equals 5, well, we would just have a vertical line at x equals 5. It would look something like this. I'm just going to use a dotted line because this actually is an x equals, but if it was x equals, we just have a vertical line here. Well, what we're doing, since we're only interested in values greater than x equals 5, we shade to the right. We don't include 5 in our solution, so we have a dotted line here at x equals 5. So we're just going to shade everything to the right. It's very similar to what we did with the number line, but we're actually looking at a two-dimensional graph. All right, so this is the graph of x is greater than 5. We use a dotted line to exclude the point 5, and we're just interested in all the values to the right. All right, let's do a few more of these. Let's take a look at the graph of x is less than or equal to 2. All right, so less than or equal to means we shade to the left with a solid line at x equals 2, indicating that we include minus 2, 2 in our solution. So x equals 2, so we have 2 right here, and we're going to draw a solid line at x equals 2. This is our x-axis. I guess we should have written it up here too. This is our x-axis, this is our y-axis. We're just getting a rough sketch of what this graph looks like. And at x equals 2, we're going to have a solid line because we're including 2 in our solution, and we're shading, we're shading all the values to the left of 2. So we're interested in all the values that are less than or equal to 2 in value. So all the values to the left of 2. All right, let's do a few more of these. Let's take a look at the following. We have x is greater than minus 2. So x is greater than minus 2. So let's take a look at what that looks like. So we have 1, we have minus 2 here. This is our x-axis, and this is our y-axis. Okay, so we're looking for all the values that are greater than minus 2, but not including minus 2. So we're going to put a dotted line right through x equals minus 2, and we're going to shade everything to the right, all the values that are greater than minus 2. And that's the value, or that's the graph of x is greater than minus 2, all the values that are greater than x equals minus 2. All right, these are fairly straightforward. We're just using what we know to graph them on a Cartesian plane. We've already been doing it on a number line. This is just a bit more to it. All right, so now we have, the next one we have is y is greater than or equal to minus 1. Now remember that every line in the form y equals a gives us a horizontal line crossing the y-axis at the given value. So we have y is minus 1 right here, and we're going to have a horizontal line crossing the y-axis at minus 1. So we're going to have a solid line, just like that. Actually, let me get you a straight line. We're going to have a solid line going through y equals minus 1. This is our x-axis. This is our y-axis. We're including the point minus 1, and we're shading everything above minus 1. We want all the values of y that are greater than or equal to minus 1. All right, let's do a few more. Let's take a look at the absolute value of y is less than 3. All right, here we have the absolute value, so we can rewrite this. Since it's less than, we know we have an and in a compound inequality. So all the values are going to be within 3 units on either side of 0. So we have -3 is less than, or excuse me, y. We're using y right here, not x. So y is in between +3 and -3. All right, we're not including the endpoints. We just want all the values within that region. So we can rewrite it like this, and this actually is going to represent 2 horizontal lines about the points y equals +3 and the point y equals -3. With our solution is going to be the plane in between. And this should make sense because it's very similar to what we looked at on a number line. So we're not including these 2 points, but we're going to have 2 horizontal lines running through y equals 3 and -3, with our solution being one shaded region in between the 2 points, just like on a number line. So that is all the values that satisfies the equation, the absolute value of y is less than 3. All right, so all the values that are less than 3 steps to 0. All right, and this was our x-axis. This is our y-axis. So these are our 2 lines. They're dashed or dotted to show that we're not including those 2 points in our solution. All right, fairly straightforward. It's just an extension of the number line of the solution graph. Let's do one more. We have x is greater than or equal to 4. Now, when we know we can actually rewrite this in a compound inequality because we have x is greater than or equal to 4. So we either have x is greater than or equal to 4 or x is less than or equal to -4. We want all of the values that satisfy the equation that are within 4 steps on either side, the negative or the positive, of 0. So let's go ahead and see what this looks like. All right, so this is going to give us 2 solutions, and the 2 solutions are going to be 2 vertical lines. There's point 4. This is our x-axis. This is our y-axis. Always label the axes. And now we have -4 over here. Now our solution is going to be the coordinate points for which the value of x is less than or equal to -4 or greater than or equal to a +4. Now we're going to include the 2 endpoints because it's less than or equal to and greater than or equal to. So we're going to have one line going through the point x equals -4 and a line going through the point x equals +4. Now both lines are going to be solid because we're including the points, and we want all the values that are greater than or equal to +4. So it's going to be all the values to the right of 4. And we want all the values that are less than or equal to -4, so to the left of -4 with the solid line there. All right, so we're taking what we know with just a simple number line or a solution graph, and we're actually putting it on a Cartesian plane, and we're seeing what the graph of 2 linear inequalities looks like. We'll do some more of these in the next video. I'll see you soon.